Good day, students. On this clip, we're going to go over how to use SOHCAHTOA to solve right triangles. Okay, so let's write down the title of this lesson. Title of this lesson is right triangle trigonometry. Okay, right triangle trigonometry. Alright, we're going to be making use of the formulas we just went over, and we're going to be applying it to three problems, okay? Let's spell the right correctly. Right triangle trigonometry. Alright, let's consider the first example. Examples. Number one, in triangle ABC, which I'll be drawing momentarily, in triangle ABC, angle B is equal to 33 degrees, and side BA equals 7. What is the approximate length? What is the approximate length of approximate length of value? Approximate value of AC. Okay, and let's say we have the following right triangle. Let me just sketch a right triangle for you real quick. We have a right triangle like this. Hold on, I'm going to rotate it. Let's say we have a right triangle like this, and I'm going to label the sides. Let's say this is A, and this is B, and this is C, and this is a right triangle. Okay, so this question is applies to this problem. So let's go ahead and do it. So before we find the length of the missing side, we need to label what we know, right? Because what we know basically determines what ratio we're going to use. So we're given angle BA, so that automatically makes this your reference angle. So this is 33 degrees. Angle B is 33 degrees. Side BA is 7. And the side we need, let's call it X. This is the side we need to find, okay? So remember, whenever you're using SOHCAHTOA, you always use a relative to one reference angle. So this is a reference angle right here. If this is a reference angle, that means that this side right here, opposite the reference angle, is the opposite. So this is a O for SOHCAHTOA. This longest side opposite 90 degrees is always the hypotenuse. Okay, it never changes. This is the H for SOHCAHTOA. And the other side is the adjacent, which is the A. Now, we know the hypotenuse, we need the opposite. That means the adjacent does not play any role in this problem, so let's scratch that. So if we write down SOHCAHTOA, which of these three ratios has H and O, or O and H? It's so, right? So what does so mean? So means sine. So we're going to go sine of whatever the angle is, which is 33, equals the opposite, which is X over 7. Alright, so is sine equals opposite over hypotenuse. That's what so means. Sine is opposite over hypotenuse, okay? So just put the opposite and the hypotenuse here. We're looking for AC, which is X, so we need to get X by itself. To accomplish that, we need to get rid of divided by 7. The opposite of division is multiply. So multiply both sides by 7. So our answer is going to be X equals 7 sine 33. Alright? The approximate value, we need to use our calculator to compute this. Sine is in degrees, so we have to put our calculators in degree form. So degree angular measure, 7 sine 33. Final answer is 3.8812. Okay, so 3.812. 3.812. That's good enough for this problem. All right, so that is basically the length of AC. So AC is 3.812. Okay? Alright, let's go ahead and try another problem. Um, example 2. In this one, find the values of all 6 trig functions for angle B. Okay? Let's consider this triangle right here. Let's say we have a triangle like this, and the side lengths are as follows. Let's say this is B, this is A, and this is C, and length side BA is 5, side AC is 12. Alright, so this problem, we're finding all 6 trig functions for angle B, so that automatically makes angle B a reference angle. Remember, SOHCAHTOA is always done with reference to an angle. Since we're finding all 6, we need to know all 3 sides. Okay, what do I mean by all 3 sides? Since this is a reference angle, the side opposite a reference angle right here. Wrong thing. The side opposite a reference angle right here is automatically the opposite. Okay, so this is the opposite. We know that the opposite is 12. And this side, the longest side is the hypotenuse. That's H. And then the other side is the adjacent. Okay. Now, we need all 6. We know the opposite, adjacent, but we need to find the hypotenuse. So how do we find what the hypotenuse is? Since this is a right triangle and we have 2 sides, we can use the Pythagorean theorem. Remember, the longest side is always the hypotenuse, so this is C. And this one can be A or B, doesn't really matter. So since this is big B, let's just call this little b. And then let's call this right here little a. Okay? So this is for the Pythagorean theorem. So Pythagorean theorem tells us that C squared equals what? A squared plus B squared. Okay? We need all 3 sides so we can use SOHCAHTOA. To do this, we're going to put in this, we need C squared, we don't know what C squared is. So we're going to have A squared is 5 squared plus B squared, which is 12 squared. So C squared is going to become 25 plus 144. And then C squared is going to become 169. So to get C by itself, you take the square root of both sides, you root this and root that. And then you're going to have C equals plus or minus 13. But since it's the side length, the negative is extraneous, so C is basically 13. Okay? So the hypotenuse in this problem is 13. Now that we have all 3 sides, we can now find all 6 trig ratios because we know H, A, and O for SOHCAHTOA. Alright? So first of all, let's look for sine. Sine B. What is sine? Let's write down the formula here. So, properly, SOHCAHTOA. Sine is opposite of our hypotenuse, right? So sine B is over H. O is what? 12. H is 13. So sine B is 12 over 13. Cosine B is adjacent of a hypotenuse. The adjacent is 5. The hypotenuse is 13. Alright. How about tan? Tan B is TOA from SOHCAHTOA, right? The tan is opposite over adjacent. The opposite is 12 and the adjacent is 5. So there goes your first 3. Now we're going to find the reciprocal functions or the reciprocal relatives to these trig ratios. So we're going to have for sine, the reciprocal of sine is cosecant. So cosecant B, to get cosecant B, you just simply do 1 over sine, right? 1 over sine B, or you just flip sine. If I flip this, reciprocate this, I'll have 13 over 12. To get cos To get next thing is secant. To get secant, you simply reciprocate cosine, or you do 1 over cosine b. Alright? And then we're just going to flip this upside down. 13 over 5, that's a reciprocal. And then the last one is cotangent b. Cotangent is a reciprocal of tan, so you do 1 over tan. Or you just reciprocate this, which is 5 over 12. And there goes your answer. So you're going to have basically have 6 answers for the question. Okay? So there you have it. Alright, now let's go ahead and try the last example. Example number 3. Write this down. Number 3, we're going to find the values of the 6 trig ratios for angle T in this case. Okay. All right. So let's say we have a triangle like this. I'm going to rotate it, so don't draw yet. So let's say we have a triangle. Oh gosh. We have a triangle like this. You can do it. Like that. And let me put in some of the measures. Let's say this is T, and this is U, and this is S. Now let's say US is 6 and T is 4, and we want to find the value of all 6 trig ratios. Now, since angle T is a reference angle, I'm going to mark this right here as a reference angle. So that tells me that relative to this side, this is the relative angle we're going to be working with, and this side right here is going to be opposite. Okay, so this is your reference angle because that's what we're finding the ratios with respect to. So this becomes your opposite. It's O. This is your hypotenuse. That's H, and this is your adjacent. The other side, that's A. Okay. Now, as you can clearly see, in order to find all 6, we need to have all 3 sides. So we need to find the hypotenuse. So this side is known as C, always C. These two can be A or B, it doesn't really matter. Okay, these are the legs. So we can call this A, let's call this A, and call this B. Alright, so applying the Pythagorean theorem, we know C squared equals A squared plus B squared. So let's find out what C is. So C squared equals A squared is 6 squared plus 4 squared. If we do that, we have C squared equals 36 plus 16. So C squared is basically 52. Now to get C by itself, you take the square root of both sides, left and right. So we're going to have C equals the square root of 52. Now how do you simplify that? To simplify root 52, we can do that over here. We can do the factor 3, root 52, take out 2, be left with 26, take out 2, 13. Alright, so these two 2's repeat themselves, so they can both break out as 1. This is 2 and that 2, they can both break out as a 2. So in essence, root 52 simplifies into 2 rad 13, because this 13 stays behind under the radical because it's by itself, okay? So for C is basically 2 root 13. Alright, now let's go ahead and generate our trig ratios, okay? Remember we're using SOHCAHTOA to find the first 3, then we'll reciprocate the first 3 to generate the other 3, okay? The reciprocal trig ratios. So let's look for sine first. I'll have to erase this work we just did over here to create room. Shift way to the right. Sine T, that's the angle we're dealing with, equals opposite of a hypotenuse, right? So that's going to be the opposite, which is 6, because the opposite is 6, over the hypotenuse, which is 2 root 13. All right. But 2 goes into 6, right? So 2 goes into itself once, and 2 goes into 6 3 times. So you're going to have, this becomes 3 over root 13. But you cannot have a square root as a denominator, so you can just rationalize the denominator. So root 13, top and bottom. You multiply it out, this becomes 3 roots 13. And then root 13 times root 13 is root 13 squared. The square and the square roots cancel out, so you just left with 13. Okay? Alright, now let's look for cosine. Cosine of angle T. That one is adjacent of a hypotenuse. Alright, the adjacent is 4. And then the hypotenuse is 2 root 13. Okay? 2 goes into 4, right? So 2 goes into itself once, 2 goes into 4 twice. So we have 2 over root 13. You can have a square root as a denominator, so rationalize the denominator. So root 13. That's going to give us 2 root 13 on the numerator divided by 13 in the denominator. Okay? Last but not the least is tan. Tan t is opposite over adjacent. How do I know that? From TOA. Tan is opposite of adjacent. So the opposite is 6 and the adjacent is 4. Opposite over adjacent. I can reduce that because 2 goes into both of them. 2 goes here 2, 2 goes here 3. So your answer here is going to be 3 over 2. Okay? Alright, now let's find the reciprocal trig ratios of these three to generate the other ones, okay? So for the first one, let's look for cosecant. So to get cosecant t, if I flip this one, I'll have a square root on the bottom and I have to rationalize to get the answer. But wait, this is the same as this, right? These two are exactly the same. So why don't I just flip this? If I flip this, the square root goes to the top and I have no problem. So if I reciprocate this, I'm going to have root 13 over 3. And I'm done. But if I reciprocated this, I would have had 13 over 3 root 13. And I'll have to do root 13, and then 13 root 13 over 3 times 13. Cancel, and then I'll end up with that, which this is too much work. So why don't I just take the one that does not require rationalization, because when I reciprocate this, the square root goes on the top. Okay? So let's take a look at the cosine. Which is smarter? Should I just use this one, or should I reciprocate this? If I reciprocate this, the square goes on the bottom, that's too much work. But if I reciprocate this, the square root goes to the square root goes to the top, and that's no work. Okay? So I'm gonna choose to reciprocate this piece instead. So for secant t, I'm gonna flip this one, and it's gonna become the square root of 13 over 2. Last but not the least is cotangent. That has no problem whatsoever because there are no square roots on the numerator. So if I reciprocate this, I'll end up with 2/3, and that's my final answer. Okay? So let me reorganize my work over here so it looks nice and neat. So I have sine t is 3 root 13 over 13. Cosine t is 2 root 13 over 13. Tan t is 3 over 2. Cosecant t, the reciprocal of sine, is root 13 over 3. Secant t, which is the reciprocal of cosine, is root 13 over 2. And then cotangent t is going to be 2 over 3, okay? So when you're doing your classwork, I'd like you to organize your work like this so that I can easily assess your work, all right? So that's that. Thanks for paying attention to this clip. Now we're going to go ahead and do some practice.